Unit 6, quadrilaterals and other polygons. We're proving quadrilaterals are parallelograms, but this is part 1. This is algebraic. Lesson 6.4, proving that a quadrilateral is a parallelogram. Remember, this is just part 1. We're not going to be writing proofs. We're going to demonstrate that a quadrilateral is a parallelogram based on its sides and diagonals. Demonstrate that a quadrilateral is a parallelogram based on its angles. Use coordinate geometry to classify triangles and quadrilaterals on the coordinate plane. We'll be doing that later using Desmos. And solve problems involving triangles and polygons on the coordinate plane. Properties of parallelograms that are sufficient to prove a quadrilateral is a parallelogram. If you show that both pairs of opposite sides are parallel, that is enough. That's sufficient information to prove that the quadrilateral is a parallelogram. You could show that both pairs of opposite sides are congruent. That is sufficient to prove the quadrilateral is a parallelogram. Show that both pairs of opposite angles are congruent. That's sufficient to show that a quadrilateral is a parallelogram. Show that diagonals bisect each other. Show that one angle is supplementary to both adjacent angles. And show that one pair of opposite sides are parallel and congruent. Those are the 5 ways that you can prove a quadrilateral is a parallelogram. So find x and y so that the quadrilateral is a parallelogram. So we're trying to force it to go by the properties and be a parallelogram. In number 1, let's see, we have x and y. If both pairs of opposite angles are congruent, so let's find a pair. Let's do those two. Let's make those equal. So 5x plus 3 is 48. Subtract 3 on both sides. 5x is 45. Divide by 5. X is 9. If x is 9, and we got to get y to work too. So those two would have to be equal. So 65y plus 2 equals 132. Subtract 2 on both sides of our equation. 65y is 130. Divide by 65 and y is 2. So if x is 9 and y is 2, that quadrilateral is a parallelogram. Okay, opposite sides are congruent if both pairs of opposite sides are congruent. So let's set those equal to each other. Let's force x to be 14. And now set those equal to each other. Let's force the y into something. So 6y minus 4 is 26. Add 4 to both sides. 6y is 30. Divide both sides by 6. Y is 5. So if x is 14 and y is 5, number 2, that quadrilateral is forced to be a parallelogram. And number 3, if diagonals bisect each other, so those two would have to be equal to each other. Let's set them equal and see what x has to be. So 4x minus 10 equals 18. Add 10 to both sides. 4x is 28. When you divide by 4, x is 7. So x has to be 7. Let's do the same thing with y. Those two would have to be congruent as well if diagonals bisect each other. So 5y minus 4 equals 36. Add 4 to both sides. 5y equals 40. Divide both sides by 5, and y is 8. So if x is 7, y is 8, that forces that quadrilateral to be a parallelogram. Continuing on, find x and y, same direction, so that the quadrilateral is a parallelogram. Number 5, let's see, we have angle measures. The two angle expressions with x's are next to each other. So consecutive angles would have to be supplementary. Supplementary meaning they add to 180. All things from day one are fair game. 3x minus 8 plus 7x minus 12 equals 180. Combine like terms. We're going to have 10x minus 20 is 180. Add 20 to both sides. 10x is 200. Divide both sides by 10. X is 20. So x is 20. I'm going to plug that in to get an angle measure, that lower left, I guess. So 3 times 20 minus 8, that angle's 52. So the expression 21y plus 2, that angle there plus 52 would have to be 180. We're using the same interior consecutive angles being supplementary. So 21y plus 2 plus 52 is 180. Combine like terms. 21y plus 54 is 180. Subtract 54 on both sides. 21y equals 126. Divide both sides by 21. Y is 6. So if x is 20 and y is 6, then that quadrilateral is a parallelogram. Looks like in number 6 we're doing opposite sides having to be congruent. So let's set x minus 10 equal to 8 because those are opposite sides. They'd have to be equal to each other. Add 10 to both sides. X is 18. So that was a quick one. The y's, the expressions are opposite themselves. So those would be opposite sides. They'd have to be equal. So 5y minus 7 equals 3y plus 1. Let's get all our x's on one side. I like to move the smallest one. So we're subtracting 3y on both sides of the equation. We end up with 2y minus 7 equals 1. Add 7 to both sides. 2y equals 8. Divide by 2. Y is 4. So if x is 18 and y is 4, that quadrilateral must be a parallelogram. More examples. So we are to find x and y again. That's going to force a quadrilateral to be a parallelogram. Let's look at our variables. It looks like the y's, both y expressions are opposite each other, so those angles are going to have to be equal. And then the expression 45x minus 1 is opposite the 134. So let's go with that first. Both pair of opposite sides congruent. So 45x minus 1's 134. Add 1 to both sides. 45x equals 135. Divide by 45 and x is 3. Okay, so x would have to be 3. Let's figure out what y is. We're going to need to set those two expressions with the y's equal to each other. So 8y plus 6 would have to equal 10y minus 4. Because we're trying to force it to be a parallelogram. Move the smallest y. So subtract 8y on both sides. We get 6 equals 2y minus 4. Add 4 to both sides. You get 10 equals 2x. Divide by 2 and y is 5. So if x is 3 and y is 5, we've got ourselves a parallelogram. Let's look at number 9. I think, well, we've got opposite angles and we have consecutive angles. So let's do opposite angles being congruent. So we can do the 8x equals 56. Divide both sides by 8. X is 7. That was quick. And then the 56 and the 3y plus 28 would have to add up to 180 because they would have to be supplementary. So 3y plus 28 plus 56 equals 180. Combine like terms. 3y plus 84 equals 180. Subtract the 84 on both sides. 3y equals 96. Divide by 3. Y is 32. So if x is 7 and y is 32, problem number 9, that quadrilateral is forced to be a parallelogram. We have now finished lesson 6-4, part 1. We're proving quadrilaterals are parallelograms, but just with algebra. Later on, we'll do proofs.